It's my pleasure to talk to you today about predictive analytics. Okay, so before I start, I just want to give a bit of background on myself. So I'm a Master of IT student, and I also work at some. In addition to this, I have a background in behavioral psychological research, and have won some awards for using open data. But however, with that said though, I'm certainly not an expert in this area, so if there are things that I'm sure there will be members of the audience who probably know a lot more about predictive analytics than I would, so please feel to correct me if I make it. So as far as I'm aware, everything I have in this presentation is accurate. So what is predictive analytics? Before I go into it, I just want to give an overview of my presentation today. So today I'm going to talk about what is predictive analytics.
Sorry, it's that one.
Oh, okay, all right. Okay, all right. What is predictive analytics? Why is it useful? And how does it actually work? Also within this presentation, I'll be doing a demo of using, there's a Titanic data set that came from Kaggle, and I'll be doing a comparison of traditional modeling techniques with machine learning, specific machine learning technique called the decision tree analysis, using R programming language. So, what is predictive analytics? Well, it's essentially a collection of various different statistical analyses which can be used to predict data. So it's pretty much everywhere. It's ubiquitous. For example, when you go to the bank and you want to get a loan, they will have predictive analytic algorithms to work out, okay, whether we should give you the loan or for example, if you're going for insurance, they will use predictive analytics to work out what is an appropriate premium to give you. I think realestate.com also uses predictive analytics for estimating your house price. So it's a very important area, and there's a lot of money and interest in this field. So it's definitely a good field for people to get involved with for your future career. So in terms of, there are two, I would characterize there are two, broadly speaking, approaches to predictive analytics. So the first is one which has happened for many, many years, which is a theory-based modeling approach. So this is where you actually come up with the actual individual predictor variables within your model. So I think the best way to explain this is by using an example. So say I'm a bank. I want to find out who do I give loans to and who I shouldn't give loans to. Now, one thing which is really important with making that decision is whether or not the person will default on their loan. So what, as a statistician in the bank, I could do is take a look at the previous bank records to see whether there are patterns within this data. See if there are important variables which determine whether or not a person actually defaults on their loan. So for example, they might look at things like a person's prior credit history and use that to examine and use that as a part of a statistical model to predict whether they will default on their loan or not. Now, whilst that is good, there are two key problems with this. The first problem is that the nature of relationship between variables change over time. For example, let's take the case of a particular suburb. If you're looking at a particular suburb, 20 years ago, those days, and income, those days, a particular suburb might be full of working class people, but then after years, it becomes people more affluent and things like that. So, just to give you an idea, so now that's a problem with theory-based model, because that means that whenever there is a change in this relationship, your statistician has to change the model. So that's one of the key problems, and this is where the beauty of machine learning algorithms lie. What machine algorithms do is essentially the computer determines the actual particular predictor variables that will form part of your statistical model. So that's what it means by what they mean by artificial analysis. So it's like, so for example, let's take this loan default thing for example. Let's say with the bank records, there might be new variables that are put into your bank records which weren't, accessible earlier. So these, with machine learning, the beauty of it is this would be accessible from them. So as I have there, the great thing about machine learning is that it automatically adapts to new data. And also, the other thing that the second key strength of machine learning is that you can find predictions within the model, which within your data, which is not very easy for us as humans to pick up on. So broadly speaking, there are two key types of machine learning. The first type of machine learning is supervised learning. So this is where for example, in the case of loan defaults, your bank records have a label on them. So what I mean by label is, if you're interested in, for example, looking at loan defaults, those records, all those records would show whether a person had defaulted on their loan or not. So that's what supervised learning algorithms are. Unsupervised learning, on the other hand, is where we don't know with our historical data whether people have, for example, defaulted on their loan or not. So it's used it's used in a sort of a slightly different way, but it can also be used to predict things like this. But what you do is using this unsupervised learning, cluster groups into based on their relationships, and then you as a person have to work out what groups do these records lie in. So it's a little bit different. Just getting into supervised learning, because I'm going to talk a little bit more about supervised learning, because I'm going to show decision tree analysis, which is a form of supervised learning. You have to, within another key important concept within supervised learning is the concept of splitting data. So what you have to do is you have to split what I mean is historical data into training data. So this is used for the purposes of actually building your model, and test data. Now, test data is where the machine learning algorithm doesn't actually know the outcome. Now, although the records actually have that it's like masked in a way. And the reason why we use that is it's essential to work out how accurate the actual algorithm is. Also, in addition to this, it's very important to do this to prevent the problem of overfitting. Now, overfitting is, to explain what overfitting is, in life, there's always coincidences in life. And as we collect data, for example, if we've got 2,000 bank records, there's a very good chance that just by coincidence, there'll be nonsense relationships that will form. So maybe people whose names start with J are more likely to default on their loan in that sample. So that's why you need this test data to make sure that what your machine learning algorithms are not, some of the predictors are not just out of coincidence. So I'm going to talk to you about decision tree analysis. So it's a very simple form of machine learning technique. It's essentially used to reach decisions based on historical data. So, for example, maybe you might have some data like who's going to cheat on tax or not. And you have data, historical data, which shows people who've cheated on tax or not, and has measured them on various different variables. So that's crucial in order for this decision tree to work. You need historical data which shows whether people have cheated, well, in this particular instance, whether people have cheated on tax or not. So a bit more, I've included like a little figure here of that particular example, a number of variables that are being measured in terms of historical data and whether people have cheated on tax or not. And based on that historical records, you can actually build a decision tree. So I think a very simple analogy of how a decision tree works is, does anyone remember, some people may have played this game, 20 questions as a kid? Yeah, so it's a bit like that. With a decision tree, what it'll do is it'll try to find the variables which most separate the decision that you're looking into. So for example, if there is a decision where 90% of people who say yes to that, like who have that particular, belong to that particular class. So for example, if it was refunds, if 90% of people who had refund as yes cheated on their tax, that's a very good, that would be considered higher in terms of the tree than something where maybe there was like 60% of people, there's like a 60-40 sort of split. And in fact, there's a thing called a Gini. The underlying way that they decide this sort of thing is, there's this thing called, they use two things. There's one thing, you might be familiar with entropy. They sometimes use that as a way of sort of working out threshold in terms of assigning this, or the Gini index, which is another algorithm, other measure of that. So now what I'll do is I'll go through a bit of a demo. So this demo, I should let you know, is based on, there's a link here by, I think his name was, the name escapes me, but he did a really great demo of how to actually do a decision tree. So if you are interested in doing this for yourself after, just follow the link. So just to show, I actually have got some data. Can you see that? Oh, that's weird. Okay. Okay, that's rather strange. You guys can't see that because, let's see. Having some technical. Maybe I'll just show. Yeah. There's some data in here. It's good. Let's see if I can get it somewhere.
It's an extended display. There's two monitors.
Oh, okay. All right.
You'll drag it to one of the signs and it should pop to this one.
Okay. So oh, okay. Sweet. Okay. Cool. Thank you so much. I was stressing out so much about that. Thank you. The dangers of doing live demo. So the data that I have here is based on, there's a website called Kaggle. Oops, what the heck? I think I'll have to drag this as well.
Can you add big in it?
So,
Can you add big in it?
sure. I'll just first show Kaggle. So this is the actual website that you can actually get this data from. So just to explain, this data is on the Titanic disaster. So it's just, it has a number of different variables that you have to essentially predict who's going to die based on these variables that they have here. So they have a number of variables like what class the passenger was from, so whether they're from first class, second class, third class, their name, their age, their gender, how much they paid for their ticket, and so they have a lot of different variables within here. So I'm going to show how to actually an example of a traditional. Sorry, did you get that? I think this second screen is kind of tripping me out a little. Okay, cool. All right, so I've uploaded they had the test and training data set in here. So as you can see here, this is the data here. And I've taken the liberty of writing my own traditional sort of theory-based model up here. So my theory is that all women, children, and first-class passengers survived, and everyone else died. So I'm just going to run this, and what it'll do is it'll save the results of this as a CSV called test theory.
Are you able to increase the font size so that we can actually see it?
Oh, sorry. Let's see. I'm not exactly sure how to do that with this one. Let's see.
Or maybe turn down the screen resolution or something?
I'm not exactly sure how to do that either. Actually, wait a minute. Sorry, I'll just go to display. Gee, wait a minute. Is that better? Oops. Is that better? Yeah. Okay, sweet. Okay, so the first, this is my model, my traditional based model. So just that all female children and first class passengers survived and everyone else died. And so this is saved, the results of this is saved in this tester, which I will now upload to Kaggle to see how accurate it is. So you just click make a submission. Okay, so and then you just click drop your submission here. So this will determine how accurate this model is. So it's silly. Actually, just silly. Just submit this. I should also let you guys know that on this website they have a lot of different competitions. Some have at the moment have prize pools of $100,000. So it's definitely, if you're interested in this area, it's a really great way of just learning, and also you could, who knows, you could win something. So yeah. Also Netflix, for example, has a algorithm where if you increase the algorithm by 1%, you get $1 million. So yeah, so there's a lot of money in predictive analytics. So as you can see here, we've scored 0.69. So that means that our model that I just put out there was about 70% accurate. So let's see if we can actually improve this with the decision tree. So these next lines are we actually implementing the decision tree. So it's only 3 lines of code, so it's very simple. And this is the crucial one, this prediction, using this predict function. Yeah. And I'm just going to say that in the decision tree. Yeah, so let's give that a try. Okay, Okay, so that's saved. So now I will import that into Kaggle. Try. Let's make a submission. And decision tree. This decision tree. Submit. Let's see how we do. So we want to be 0.6985. So let's see how we go. Wow, yeah, so we got 0.78, so we improved almost by almost 10%. So yeah, so we've so that's a bit of just a demonstration of what decision trees can actually potentially do. Yeah, so I'll just also show a plot I did earlier of that actual decision tree. So it goes to show that sometimes you can see within here, to explain, it might be a little bit hard to actually see on there, but it's been broken down into, like, the very first question is whether the person is male or female. So if they're male, they have a 38% chance of survival. That's denoted by 0.38. And if they aren't, they have a 62% chance of survival. Now, the second question, I believe, is whether if their age is greater than, I think it might be 8.6. If they're I think it's, you have an 81% chance of survival if you're younger than 8.6 and you are a man. Whereas if you're older than 8.6, you only have a 19% chance. So it's like it goes through all these different relationships and things like that. So it can pick up on things which may not be necessarily apparent. Like, for example, the person embarked from Southampton. If you embark from Southampton, it seems like there is a bit of a trend indicating that if you embark from Southampton as opposed to Queenstown or Cherbourg, you actually have a marginally increased chance of surviving. And I was thinking that seems kind of, it could just be, as I was saying, coincidence with the data, but also another possible explanation is Southampton was a wealthier area than Queenstown and Cherbourg. So that's what I'm talking about in terms of with machine learning. It can pick up on things that might not immediately be apparent with your data if you were to do a traditional theory-based approach. So unless anyone has any questions, I'd like to conclude my presentation. I hope. Thank you for being patient and not getting angry with all the technical issues that we had earlier. Yeah, so does anyone have any questions?
We'll have time for one question. All right then. Looks like we've understood everything perfectly from your voice. Thank you very much for your presentation, and have a box of chocolates.
Awesome. Thank you.